Hi, today's notes are an introduction to Chapter 5, Radical Functions. Before we start Chapter 5, we do need to review some properties of exponents. And the thing we want to know is that an exponent has a base, which is the number on the bottom, and then it does have, oh, that's much better, sorry about that, and then it does have a small number up high, which is an exponent. The base is the number that we're multiplying. So if we have 2 to the 5th power, that means I'm multiplying 2 times 2 times 2 times 2 times 2. There are 5 2's. So the exponent tells you the number of bases there are. A term with exponents is considered fully simplified when each base shows up only once. So if you take a look, number 1 down here is not fully simplified because I have 2 x's. And then it is only considered fully simplified if all exponents are positive. So that's important as well. So let's take a look at simplifying expressions. Now, one thing I'm going to tell you is that there is a shortcut to make this happen, but I'm not going to actually tell you the shortcut. I'm going to tell you today that you need to expand your bases. So what we're going to do is going to take each piece and notice that this is 2 to the 5th, so that's 2 times 2 times 2 times 2 times 2. And then this one is 2 to the 3rd. And that means we're going to have a total of 2 to the 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, 2 to the 8th is an actual number, so we do need to know how to type that in. So the first thing you should know is that we have 2 to the power of, that's right above your division symbol, to the 8th. And that way you don't have to times 2 times 2, right? Write it all out. So that's going to give us 256. So this one was 2 to the 5th. This was 2 to the 3rd. Okay. This next one looks a little bit different. So we have this parentheses, and it tells us here that there are 3 sets of those parentheses. And in each parentheses, there's a 4x times x, which is x squared, and 4 times x times x, 4xx, which gives me a final answer of 4 to the 3rd, right? I have 3 4's, x to the, I think there's 6 of them. And the final answer you want is not 4 to the 3rd, but it's 4 times 4 times 4, which is 64x to the 6th power. This is not the same as if you had 4 parentheses x squared to the 3rd power. That would be written as 4 times x, x times x, and x times x. Did I see the difference there? So in the one that I just made up, you only have 1 4, and there's 3 groups, but they don't all have a 4 in it because the 4 is outside. The next thing we want to tackle is fractions. Well, if we break this up into 2 pieces, 32 divided by 8, oh, sorry, I just wrote 8. 32 divided by 8 is something that we know already, right? We know that's 4. And then we're going to have all of our x's expanded. There are 9 x's on top. There are 7 on the bottom, and you want to be sure to line these up neatly, because what's going to happen is that 7 of these pairs of x's are going to cancel out because x divided by x is just 1. So my final answer is 4x squared, because I have 2 that are not canceled out there. So what do we do if we have 10 and 12, which don't divide nicely? Well, 10 over 12 is a fraction that we could reduce. Hopefully you see that we can divide by 2 and divide by 2. So that will be 5 over 6. If you don't know that, you can also use your graphing calculator. 10 divided by 12, and then go math, fraction, and that'll convert it and reduce it for you. Well, then we have 7 x's on top. This one's different because the 9 x's are on the bottom. this y, now it looks like we have a single y, but if you look at that exponent, that's a trick. That 0 means that there are 0 y's, so it's all gone. Okay, not the x and not the 10, but that y, which is a base right next to the 0, is gone. So we're going to cross out 7 pairs of these. And there's 2 x's left over just like there were here, but the 2 x's have to actually physically be in the bottom or denominator of your fraction, because that's where it shows up, right? You can't put it next to the 5, and you can't put it in the middle. Putting it in the middle implies that it's on top. Okay, that really just concludes my lesson. The only thing you might want to know about is, like, what do I do with these parentheses versus this one? This parentheses is the same as like 3 times 2 versus 3 parentheses 2. Are those the same thing? Hopefully you know these are equal. Right? So if you have 2 parentheses with things inside of it, there's just two x's in here and there's 3 x's in here. And you're just still counting up how many. Make sure you read the directions here to see what goes in this. But what you're going to do is show all your work, and this paper is extra credit if you do complete it. There might have been a few mistakes. I think if you got my original version, W and Q are fixed right now. Okay, so if you're checking that on the original version, this one used to be a 6 and this one used to be a 5, but use the one that you see here. Those are the correct ones. Tomorrow, or in a separate video, I think what I'll do is have a separate video to talk about the rules and what the shortcuts are, but I don't want you to learn the shortcuts before you learn how to expand these, because if you forget a shortcut, you are going to be in trouble on the test. But if you forget a shortcut and you know how to do this expansion, you can figure any problem out, regardless of how complicated it is.